Hello everyone, this is Swekshya and the topic on the presentation is statistical hypothesis. So and my group mates are Amanjot, Maansi and Rhythm, and we are going to present on statistical hypothesis testing. So statistical hypothesis testing is a statistical method used to determine if there is enough evidence in a sample data to draw a conclusion about the population. So basically, there are two types of hypothesis: null and alternative. Null hypothesis, in a simple language, you can say that it is a statement assumed to be true unless it can be shown to be incorrect beyond a reasonable doubt. It is also written as HO. Uh, Alternative hypothesis is a is an opposing theory to a null hypothesis. For an example, if null hypothesis predicts something to be true, the alternative hypothesis predicts it to be false. The alternative, hypo- the alternative hypothesis The alternative hypothesis often is the statement you test when attempting to disprove the null hypothesis. Now we are hopping into t-test. A t-test is a statistical test that compares the means of two samples. It is used in a hypothesis testing with a null hypothesis that the difference in a group means is zero, an alternative hypothesis that the difference in a group is different from a zero. A t-test is used when sample size is less than 30 and the population variance is unknown. There are three types of t-test: one sample t-test, two sample t-test, which is also called unpaired t-test, and number third one is two sample paired t-test, which will be further described by my colleague.
So I'm going to present introduction unpaired t-test. The unpaired t-test is a statistical method used to compare the means of two independent groups, assessing whether there is a significant difference between their average values. Unlike the paired t-test, this test compares observation between separate and unrelated subjects or entitles in each group. By analyzing the means of two distinct groups, the unpaired t-test helps determine if any observed differences are statistically significant, guiding researchers in understanding disparities or effects between unrelated sets of data. Here is the difference between unpaired t-test and paired t-test. Data structure. Unpaired data involves two completely separate and independent groups with no inherent pairing of relationship between their data points. On the other hand, the paired t-test involves related or matched observation within the same subjects or entitles. Observations in one group are entitled unrelated in unpaired t-test, and the data point in one group is related to connected to a specific data point in paired t-test. The example of a paired t-test is test scores of two different groups of students where there's no link or pairing between individual students from each group. On the other hand, the example for paired t-test is pre and post treatment measurements on the same individual or measurements on the same subjects under different conditions. The key elements: two independent groups. Data from each group are not related or paired in any way. For example, one group might be a control group while the other receives the treatment, or they could be two entirely separate populations. Assumptions: both groups should have normally distributed data. Hypothesis: there are two types of hypothesis. The null hypothesis: there's no significant difference between the means of the two independent groups. Alternative hypothesis: there exists a significant difference between the means of two independent groups. The calculation of the statistics. The formula for the T statistics in the unpaired T test involve the difference between means and accounts for the variance within each group and the sample sizes. The t value is calculated to assess the likelihood of the observed difference occurring due to chance. This is the formula for t statics and the to determine the degrees of freedom. Examples. So here's a scenario. Imagine we want to compare the effectiveness of two different weight loss programs, program A, program B. We have two independent groups of participants, one following program A and other following program B. We are interested in determining if there's a significant difference in the average weight loss between the two programs. So the group 1, 25 participants with an average weight loss of 8 pounds and a standard deviation of 2 pounds. Group B, 30 participants with an average weight loss of 6 pounds and a standard deviation of 3 pounds. Hypothesis. Uh, Null hypothesis. There's no significant difference in the mean weight loss between participants in program A and program B. Alternative hypothesis. There exists a significant difference in the mean weight loss between participants in program A and program B. Conducting the unpaired t-test, calculate the t-statistics using the formula for the unpaired t-test, which involves the difference between means and accounts for the variance within each group and their sample sizes. Degree of freedom. Calculate the degrees of freedom based on the sample sizes of two groups. To find the critical value at a chosen significance level, example alpha is equals to 0.05. Obtain the critical value from the t distribution table. Comparison with the critical value. Compare the calculated t value with the critical value. If the calculated t value exceed critical value, reject the null hypothesis. The next part is pair t-test, which will be continue by Maansi.
I'm going to present the topic, the pair t-test. The pair t-test is a statistical method designed to compare the means of two related groups or conditions, analyzing paired measurements or observations from the same subjects. It serves to determine whether there exists a significant difference between the paired values, aiding in understanding the impact of interventions, treatments, or changes within a study. By assessing the difference between paired measurements, the paired t-test helps researchers discern whether observed changes are statistically meaningful or merely due to random variability. Its application spans various fields from medical research evaluating treatment effectiveness to experimental studies measuring the impact of interventions over time. Okay, so now hopping on to the conducting a one-tailed paired test, data collection. Obtain paired data, often before and after measurements on the same individuals or related entities. Formulate hypothesis. Determine the specific directional hypothesis based on the context of the study. Calculate the t statistic. Use the formula for the pair t test to find the t value. Formulation of hypothesis for a one-tailed or pair t-test. So the null hypothesis here, the mean difference between the paired measurements is zero. Alternative hypothesis, the mean difference is either significantly greater than zero or significantly less than zero. Conducting a one-tailed pair t-test, determine a critical value, look up the critical value from the t distribution table based on the chosen significance level and degrees of freedom. Compare calculated t-value and critical value. If the calculated t-value falls in the critical region, either greater than the critical value for a greater than test, or less than the critical value for a less than test, then you reject the null hypothesis. Interpret results. If the null hypothesis is rejected, it suggests that the mean difference is significantly in the specified direction, greater than or less than 0. So here's an example. Um, Imagine a scenario where a group of students undergo two different studying techniques, Technique A and Technique B. To assess the effectiveness of these techniques, uh, their test scores before and after each technique are recorded. Example, we want to determine if there's a significant difference in the mean test scores before and after each technique by using pair t-tests for technique A and technique B separately. We can evaluate whether the mean difference in test scores for each technique is statistically significant. For instance, if we conduct a pair t-test for technique A, null hypothesis, there's no significant difference in mean test scores before and after technique A. There's a significant difference in the mean test scores before and after technique A. Suppose after performing the pair t-test, we obtain a t-value that exceeds the critical value for a given significance level, example 0.05. In that case, we reject the null hypothesis, indicating that there's a statistically significant difference in test scores before and after technique A. This would suggest that technique A has had a discernible impact on the students' test scores. Similar analysis can be conducted for technique B or the paired data sets to assess their respective effect of changes or changes. That's it from my side, and Amanjot, you can take it over.
So, as my friends have explained what is actually a t-test is and how we can use it, I will be showing how we can use the calculator and how we can actually put the t-test in real-time use. So, so sample t-test is commonly used in two scenarios. Basically, a measurement which is taken before and after some treatment. For example, a maximal vertical jump of college basketball players is measured before and after participating in an training program. Another example will be a measurement is taken under two different conditions. For example, a response time of a patient is measured on two different drugs. In both the cases, we are interested in comparing the mean measurement between two groups in which each observation in one sample can be paired with observation in another sample. So this is going to be the formulas for the paired sample. As you can see, we will use null hypothesis as well as alternative hypothesis. This is the formula that we're going to use for the paired t-test. And the most important thing is the assumptions. Now, the assumptions are for the result of a paired sample t-test to be valid, the following assumptions should be met. The participant should be selected randomly from the population. The difference between the pairs should be approximately normally distributed. There should be no extreme outliers in the difference. Now, for example, we want to know that whether a certain training program can increase the maximal vertical jump in inches of college basketball players. So to test this, we may recruit a sample random of 20 college basketball players and measure each of their maximum vertical jumps, then we may have each player use the training program for 1 month and then measure their maximum vertical jump again at the end of the month. To determine whether the training program influenced maximum vertical jump, we will perform a t-test at a significance level of 0.05 using the following step. So this is going to be our data set that we're going to be using. We will be taking 20 random data, and then we will be using our hypothesis. Now, what is the hypothesis? We have two hypotheses. One is the null hypothesis, and another one is the alternative hypothesis. Now, I will be showing that we will be using the GraphPad Prism as our calculator. I'll be showing you live that how it can be used. So when we open the GraphPad Prism on our browser, there will be a screen showing us to where we will fill our data, maximum jump before the training and after the training. We will include the data in the columns given, and then we will be selecting which kind of the t-test we will be performing. We can select either unpaired or paired. At first, we will be using unpaired t-test. After calculating, we can see that we will be having all the results on our screen. Now, we will be seeing that in the paired t-test, our significance level is 0.04. And now we will also be doing the unpaired t-test, the paired t-test. As we can see, by using this calculator, we can easily find out the results for either paired t-test or unpaired t-test. Now, at the last, the conclusion will be we can see that the p-value is less than our significance level of 0.05. Now, we can reject the null hypothesis because we have sufficient evidence to say that the mean maximum vertical jump of the player is different before and after participating in the training program. That will be everything from our side. Thank you so much.